Good morning, guys. Can you hear me?
Yes, we can hear.
So yeah, that'll be better. So yeah, let's go to the final exam review. If you open it, you should be able to see the exact same version of the final exam review. So I just changed it to one version only. Okay. All right, so let's start with the question number 1. So suppose a brand new light bulb runs on average 1,789 hours for standard deviation 120 hours. I want to find out probability that lasts from in between, right? 1,431 hours and also 1,952 hours. So first of all, we're gonna draw the bell curve and try to visualize this. Okay. Let me just screenshot this so I can explain the question to you. Share the screen. Go. You can see my screen, right? Okay. So first of all, we're gonna draw the bell curve. And let's put a mean and then center. It's 1,789 hours. And we have two light bulb light, which is one of them is 1,001. The other one is 1,052. Okay. So now we want an area in between. Okay. This area. So first of all, we're gonna convert the light of the light bulb, right, which is the bigger value first. So when the first one x equal to 1,000, we do using the z-score formula, x minus mu for sigma. And the mu of sigma is given. So mu says sigma is 128 hours. Both. So put all the numbers into the 1,2 minus 1,789 over 128. Let's also try your calculator. So I'm gonna show you in Excel and see that Excel open. Not yet. Just open Excel. So find the z-score first. Same thing for the other life rate, which is 1,431. And once you have both z-scores, and then we're going to go to table A2, look at both probabilities, and find the difference afterwards. Okay, so first one, let me share the screen with you. So equal sign first, open parentheses, 1952 minus 1789 by 128. Okay. And let me double check numbers. Yep, that should be good. 1952, it's good to go. Go back. Yeah, let's see what that is, right? Hit enter, get 1.27, and we only need 2 decimal place. So we just highlight this column and then format a 2 decimal place. Okay. For some reason, my computer is a little slow today. It's okay. Yeah. Okay, so approximately 1.27. Run it to decimal place. 1.27. And also we're gonna find the z-score for the other x values x equal to 1. So the z-score equal to x minus mu over sigma. Okay. Similarly, the numbers 1, 3, 4, 1, 3, 1 minus 1, 7, 8, 9. Close parentheses, dividing by 128. Let's see what the z-score is. All right, one more time, we're going to use Excel. This is 1431 minus 1789, close parentheses, divided by 128. Okay. Now here enter, we get a result. So this one is negative 2.80. Yes, now it's better. Two decimal place. Okay, so that's negative 2.80. That's what we use for the z-score. Negative 2.80. Now again, we're going to use the bigger z-score first, right? To find a bigger probability. Let me go to the open the formula sheet. See if it is open yet. Let's start. Okay. Go to Blackboard course, open the sheet. Go to the center. Go to Blackboard. One more time, you guys can also go to Blackboard or Blackboard course. Go to that. Meanwhile, you guys can try it, right? Look up in table A2. Well, I'm going to show you in a second. So it's our Blackboard course. So that should be 5,000. Yeah. So, okay. Let's go to syllabus formula sheet. And open a formula sheet. I'm going to scroll down to the table A2. So this is table A2, and the positive value is on the second page. So we're going to look up 1.27 first. And 1.27, it gives us 0.8980. 1.27, right? 0.8980. Go back here. So this gives us probability. So the bigger area here is 0.8980. And I'm going to subtract the smaller triangle area on the left tail, which is corresponding with the negative 2.80. Now, one more time, go to table A2, the first page, negative 2.80. So it's going to be 0.0026, right? Here you go. So 0.0026, that's the difference. Okay. 0.026. Okay, the difference will be 4. 0.8954. So the answer here is 0.89. And let's go back and put it in to the lumen. 0.895. Right, let's see. Any questions? Yeah, good answer. Okay, so we're gonna move on to question number 2. Let's see. So this question have 3 components. So the question number 2 actually covers all 3 scenarios. Less than, so area to the left, area to the right, area in between. The screen one more time. Share the screen one more time. Okay, here we go. So we know the mean, we know standard deviation. So the mean is 42.1. Standard deviation is. Let's start with the first scenario, which is less than 44 inches. We draw the bell curve. Mean goes in the center. Mean is 42.1. And then now the x value is 40. Okay, so we want an area to the left. So everything to the left. Okay. Now, first of all, we're going to convert the x value to z-score by using z-score formula. So z-score equals to x minus mean. Will be 44 minus 42.1. Okay, and divide by 5.5. Okay, so let's see what the value is. I'm going to try that in a calculator. Jason. Okay. So my calculus 1 students here. So when I finish this question, I will have to help him with one question, and I come back to you guys, right? All right. So here you go. So go back here. Now I'm gonna put in the Excel equal to parentheses 44 minus 42.1 and dividing by 5.5. 5.5. Okay, and then he enter, you get 0.35. Yeah. So the z-score here is 0.35, approximately. One more time, we're gonna go to table A2, right? And whichever we see from the table A2, that's the answer we're looking for. One time, go to this negative 0.35. So we'll be on the second page of table A2. And 0.35. Okay. And so that's 0.6368. Okay. So yeah, so that's the area to the left. That's what we're looking for, 0.6368. 0.636. Okay. All right, so that's going to be the first part, right? And we also have a second part. What percent of the year we have annual rainfall more than 39 inches? So one more time, I'm going to draw this. And actually, we want area to the right this time. And x value is 39 inches. Actually, we want area to the right. So one more time, we find a z-score. X minus mu over sigma. 39 minus 32.1 over 5. So that's going to be the, so let's see what that is. And bring to the Excel. Equal to open parentheses 39 minus 42.1 divided by 5.5. So negative 0.56. So let's go back. Negative 0.56. So again, we go to the table A2. First of all, we look for the area to the left, and then using the total area 1 minus area to the left. So negative 0.56, negative 0.56. You're going to see 0.2877. And 0.2877, again, that's area to the left. 0.2877, right? It's right here. 7. And since we want an area to the right, so we're going to use 1 minus 0.2877 to get area to the right. It's 0.7123. So this is 71.23%. This is 63.68%. And then the last one is area in between. So similarly, we're going to draw the bell curve. And 42.1. Okay, and the x on the left is 37, and then x on the right is 43. So again, we want to average between. Okay. So first one, we find a z-score for x equal 43. So z-score equal to x minus mu over sigma. So 43 minus 42.1 and divided by 5.5. See what that is. Minus 42.1 divided by 5.5. Okay, he entered 0.16. So here the bigger z-score is 0.16. And then look for the smaller z-score here, actually 37. So the z-score equal to x minus mu over sigma. So that's going to be 37 minus 42.1 over 5. That's going to be, let's see, equal to 37 minus 42.1 over 5.5. So let's see what that is. Negative 0.93. Negative 0.93. And again, we're looking for the bigger z-score. Using the bigger z-score, find a bigger probability first. Using 0.16, find the corresponding probability first. 0.16. That's going to be 0.5636. Okay. And 0.5636. 0.5636 minus a smaller z-score, which is negative 0.93, negative 0.93. And so the corresponding probability is 0.1762. 1762. And the difference is the answer, so it's going to be 4, and that's going to be 7, 8, 0.3874. So if you convert it to percentage, it will be 38.74%. Yeah, so I'm gonna answer my calculus 1 students some of the questions, right? So I get back to the final exam review. Okay. Okay, Jason.
Yeah.
Yes, you have a question?
Yeah, for the review, question 6.
Question 6, sure. Okay, so let's go back to the review sheet. All right. Okay, so you want me to go to your version, right? So let's go to your version.
Yeah.
Progress. Jason. Oh, exam number 3 review. Great job. And question 6, right?
Yes.
Okay. Here we go. Yeah, so indefinite integral. Okay, so first of all, let me print the screen. First of all, we're going to expand this perfect square, right? That's what we're going to do first. So expand that perfect square. We'll go from there. Show the screen. And so the integration of, so this is definitely integral 0.5. Now when you expand this perfect square here, first term is x squared. Our second term is 2 times negative 3 times x is negative 6x, and then 3 squared, that's 9. Okay, dx. All right, now basically we're gonna find the antiderivative first using the power rule, right? So it will be x2 plus 1 over 2 plus 1. And the second one will be 6x1 plus 1 over 1 plus 1. And the last one, the constant become linear term, not x. 0.5. Okay, are you following so far?
Yes.
Okay, very good. So it's going to be x cubed. Okay. Minus 6x squared over 2, that will be 3x squared. And adding that x. And it's from 0 to 5. So throw in the 5 first. So we're going to get 5 cubed over 3 minus 3 times 5 squared. Adding 9 times 5. And then if you put in the 0, everything becomes 0, right? So we don't have to do that. And then it's going to be 125 over 3. Minus 3 times 25, that's 75. And 45. And simplify will become 125 over 3 minus 30. 30 is a 90 over 90 over 3. So the difference is 35 over 3. Okay. So that's the answer.
Okay, thank you.
Okay, no problem. So I'm going to answer my Math 150 students, right? They also have a final coming up today. So want me to review some of the questions. I will come back to you, right? When I finish the question. Okay. Yeah, so question 3. Yeah. Screen. Okay, so the question 3, you're gonna need a central limit theorem because I'm sure that with you first. Because we have a randomly purchased component. So first of all, manufacturer have a normally distributed lifespan, items. The average population mean is 12.5. Population standard deviation sigma is 3. And we have a sample of 10 items, sample size. And when this happens, right, when you have a sampling distribution, this is what they call a sampling distribution. You pick a sample. So we have a sampling distribution involved here. Now we're going to use the central limit theorem. So we have sampling distribution. So still we're going to draw a bell curve. And we're going to put all the useful information here. So mean goes to the center. In this case, it's average life, right? Mean life is average life longer than 10 years. So x equal to 10. X sample mean equal to 10. And longer than that, meaning one average. Okay. So we're gonna convert in this sample mean, all right? Mean life using the z-score formula, which is sample mean minus population mean divided by population standard deviation of square root sample size. So it's gonna be 10 minus 12.5 over 3 over square root 10. Okay, and then we find the z-score first. Now I'm gonna go to the table A2. Let's go to table A2. So here, no, let's go to Excel first. And minus 12.5, 10 minus 12.5 divided by open parentheses. Standard deviation is 3 by square root of 10. Close it, and that will do it. Let's see what that is. So it's negative 2.64. That's a z-score. Negative 2.64. Okay. Now we're going to go to table A2. Look for the area to the left. Negative 2.64. 2.6 and 2. So it's 0.0041. 0.0021, that's area on a scale right here. 0.001. Do 1 minus 0.0041. That's 0.99. So that's going to be the answer, 0.9953. Okay. Yep, it's good. Okay. So I'm gonna quickly go over this question and I will return to Jason's question in a second. Okay. So one more time, still gonna for the next question, question 4. Still gonna use central limit theorem because there's a sample involved. Right? 11 fruits were picked at random, so that means we are using the central limit theorem. So mean here it's 7. Standard deviation is 35. And we draw the bell curve. So the mean is in the center, 6, 7. So we have 2 average weights. one of them is 634, the other one is 646. So x equals 600 sample mean. One of the mean is 634, the other one is 646. And then we want area in between. Okay. So first of all, we take in the bigger average weight x5 equal to 646. Let's apply the central limit theorem. This called the sample mean and population mean over same formula sigma over square root of sample size. And sample size here is 11. So again, we throw out the numbers: 646 minus 607. No, yeah, it is. So I'm divided by 35 over square root of 11. Okay, and first of all, let's find the z-score first. Okay, equal to 647 minus 636. That's my number. 646 and 627. And divide by quantities. Standard deviation is 35 over square root of 11. Okay, so now key enter, we get a result, right? So we'll be 1.80. So that's bigger z-score here. 1.80, bigger average weight, bigger z-score. Now we're going to use a smaller average weight, right? Which is 634. And with the 634, average weight is 34. Now the z-score is sample mean, same formula, population mean over relation standard deviation, so sample size. Now one more time we go to numbers. 634 minus 627 over 35 square root of 11. Yes, so let's see what that is. 634 minus 625. Parentheses 35 over square root of 11. Okay. And now he enter the result 0.66. And this goes 0.66. Right, so now we're going to find the area for this one first, right? For bigger z-score first, which is bigger area. So bigger z-score gives bigger area. Go back to table A2, look for 1.80. 1.80. Second page. 1.80 is 0.9641. So 0.9641. And minus the smaller z-score gives us a smaller area, 0.66. 0.66. Okay, so it's 0.7454. And the difference is the answer, 0.7454. 0.7454. Okay, so if I find the difference, that's going to be 7, 8. And you don't have to do it by hand, right? You can just put into the calculator. I just want to save some time, so 7. Yeah, that's right. 13. 1. Yeah, okay, so it's 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.2187. Yep, that's good. So, Jason, what's your next question?
Wait, can you go back real quick?
Which one? Which?
To the problem.
Oh, actually, I'm gonna send you guys this video later. I'm gonna record it and email to you guys, so you can review as much as you want. Let's see, yeah. So, but yeah, I can go back, sure. So you have something, to go back. You mean here?
Yeah, thank you.
Okay, so yeah, Jason, what's your next question?
Question 7.
Question 7. Okay, question 7. Melody, you finish or you're still looking at
No, I'm
it?
finished. I'm done. I'm done.
Okay, very good. All right, so let's go to question 7. Next problem. All right, so indefinite integral one more time. So yeah, so let me share the screen with you. So one more time, this is the indefinite integral. So what you have to do is divide into that. So you're gonna go under 3, 2x squared by x squared is 4. And 2 over x squared, you can write it as 2 times x to the second power and dx. Are you following so far?
Yes.
Okay. You divide into that, right? Nice. Separate into 2 terms, but for the second term, 2 over x squared. In order to use a power rule, right, we're gonna do 2 times x to the second power. So flip the top, becomes negative power. So now we're gonna continue. So it's gonna be so let's take the antiderivative and the result first. This 4 becomes 4x, right? The other one is 2 times x negative 2 adding 1 over negative 2 adding 1. Just the power rule. And 1, 3. Now simplify, we get 4x, and that one is 2 to x negative first over negative 1. Still, we're going to simplify a little bit more. Plus minus 2 over, flip that to the bottom, 2 over x. Minus 1 to 3. Now I'm going to throw in 3 first. Upper limit goes in first. So 4 times 3 minus 2 over 3. Okay. And minus, and 1 goes in there. 4 times 1 minus 2 over 1. Okay. And to simplify, I'm going to continue here. It'll be 12 minus 2/3 first open 8. And his second parenthesis 4 minus 2. 4 minus 2 is 2. So it's 12 minus 2/3 minus 2. 12 minus 2 is 10. 10 minus 2/3. 10 is 30 over 3. Minus 2 over 2/3. 28 over 3. Okay. Is that good?
Yes, thank you.
Okay, no problem. So I'm gonna answer my all 50 student questions right now. So question 5. Okay, so question number 5. Screen. So this one is a quick one. So we are given the p hat. This is p hat. We are given margin error. So they want you to put in interval form. In the interval form, it will look like this: p hat minus margin error. But in the decimal form. So that means we're gonna convert p hat to decimal numbers, and also margin error to decimal numbers. So p hat here is 49.3%, is 0.493. The margin error is 5.9%, so it's 0.059. Okay, now we just throw into the here, going to this interval here. So it will become p hat 0.0493 minus 0.059. That's a lower limit, upper limit is 0.043 minus 0.059. No, adding, right? On the right hand side is adding. And simplify, you get 0.0, what is it? 0.493, like that. That's type of here. It's 0.493. So 0.493 minus 0.059 is 0.043 and 4. Okay. And on the right hand side, point will be 0.05.
Sí, estaba caminando.
So this one, the other one is 0.552. Okay, so the answer you want to put in here is 0.434 and then 0.552. We're just turning one form into another. That's what we're looking for. 0.4552. I'll do it. Okay, then submit it. Perfect. Okay, so one more question. Question 6.
Professor,
Yes, Lucia.
hi. Can you go over the question number 8?
Yeah, sure. So I guess we're gonna go over question number 8 first. Anyway.
Thank you.
8, no problem. Okay. Question 8. Yep. Okay. So it's confidence interval. Question 8 on the screen. All right. Share the screen with you guys. Here we go. So we are given the sample size. We are given the p hat. P hat is 0.05 and q hat is complement 1 minus p hat is 1 minus 0.05, 0.95. And we also know the 90% confidence. That means we know the critical z-score. ZR power 2 will be 1.645. If you know sample size, p hat, q hat, critical z-score, and go back to the table A2, the formula sheet. The formula we are using is this formula, margin error formula. So critical z-score times square root of p hat q hat over sample size. Let's go back here. So margin error first. Critical z-score square root of p hat q hat over sample size. It will be 1.645 multiplied by square root of 0.05, 0.95 over 410. And now one more time, I'm going to show you in the Excel how to compute the equation here. So it's going to be equal to 1.65 times square root of 105, 0.95 over 110. And key enter, we get a result. So it's 0.02 decimal is true. Wait, also, we're going to need more. I'm going to keep as 4 decimal. 0.0177. That's what we're going to keep. 0.0177. 0.0177. Okay. Now p hat minus margin error. That's the lower limit, and then P goes in the center, and then P hat plus margin error goes to the right hand side. We know P hat is 0.05 minus 0.0177. The right hand side is 0.05, adding 0.0177. So the difference here is 0.03. The other one is 0.51, no, 0.0677. So the P is between these two numbers. 0.0323, 0.0677.
Professor,
Yeah, sure.
can you explain how you got the z-value for the 90% interval?
Definitely. So we're gonna go to the table A2, and then you scroll down to the second page of the table A2. You're gonna see critical values, right? You see? And with the 90%, meaning confidence level is 0.90, so the corresponding critical z-score is 1.645. And
Okay, got it.
for 95% confidence, 1.96, 99% confidence, 2.575. All right. So that's how we get that. All right. Okay, then anybody else want me to go over any questions on it?
Yeah, can you go back to the question you were at? I think it was
Yes,
6.
question 6, yes, sure. We'll do that. Also very good question, so I'm gonna share the screen with you. Second. Okay, so measure 22 textbook weight. That means the sample size is 22. All information here, label that, and the average weight is, so for the sample mean, is 80 ounces. Assume the population standard deviation, so we are given a population standard deviation that indicates we are using critical z-score. And based on 95% confidence, critical z-score is 1.96. Okay. So basically we have everything we need, right? Everything we need to calculate the margin error first. Margin error is critical z-score, population standard deviation over the square root of sample size. We go back to the formula sheet really quickly. It's right here. We could go up a little bit, and that's the formula here. So when sigma known, we are using this formula, and then construct the 95% confidence interval using that trilinear inequality. Okay. So right here, let's see. So we're throwing on numbers 1.6 times 3.3 over square root of 22. And let's get a margin error, right? If only want two places, meaning 2 decimals is good enough. But if you keep in more decimal, that's okay, right? The system will take more accurate answers, but not less accurate. So here, let's so 1.6 times standard deviation. Definitely, you can use a calculator. Right? We can get used to a calculator. 3.3 over square root of 22. 3 over square root of 2. All right, so that will do it. And you hit enter. So the answer is 1.38. Here, the margin error is 1.38. So now the sample mean minus margin error, that's lower limit. Sample mean, adding margin error, that's upper limit. We know the sample mean, 80 ounces. 80 minus 1.38, lower limit. 80 plus 1.38, upper limit. 80 minus 1.38, that's 78.62. 80 adding 1.38 is 81.38. So go back. 62. The mid is 80.38, 81.38. That will do it. And so perfect. Right. So I'm gonna answer Jason. Jason, what's your next question?
8.
Question 8. Question 8. All right. Okay. Just screen. All right. So first of all, if you throw in the 0 here, right, you're gonna get a 0 goes in here. You have this e to the 0 negative 0 minus 1 plus 0. On the bottom is 3 times 0 squared. So e to the 0 is 1. So it's 1 minus 1 on top. On the bottom is 0. We get negative 0 over 0. So this is indeterminate form. When you do the direct substitution, we get indeterminate form. Okay, so then that means we can use L'Hopital rule, meaning, and so we just simply take derivative on top and derivative on the bottom. Derivative on the top, e to the x becomes e to the x, and derivative, so if you folio this, you get -1 and minus x. So it's derivative negative 1 is 0, right? At 0, derivative negative x becomes -1. On the bottom will be 6x. Let's just simplify a little bit. So we need 0 if e to the x minus 1 over 6x. Now again, not the answer yet. If you throw in a 0, we're going to get negative e to the 0 minus 1 over 6 times 0. So it's negative 1 minus 1, which is 0, over 0. Negative 0 over 0. So still indeterminate form, not good yet. So we're going to, one more time, we're going to take in the derivative. Limit. So e to the x is e to the x. Negative 1 becomes 0, so that's gone. On the bottom, it just becomes 6. Are you following so far, Jason?
Yes.
Okay, very good. So then simplify. So we plug in a 0 right now, right? That is good. 0 goes in, becomes negative e to the 0 over 6. E to the 0 is 1, so it's negative 1 over 6. All right. And that's the answer for this limit. All right.
Thank you.
All right, no problem. Okay, I'm gonna go back. So I can only go over one more question. So you guys tell me which question should I go over? 7, 9?
Honestly, I'm having a really hard time understanding the standard deviation and finding the margin of error. So if we can do a question that covers both of them again.
Yeah, it does. Actually, the other two questions, both of question covers that actually. So yeah, this is the this is very similar to the one I just went over, like the previous textbook question, right? So I guess I'll go over question 9, and then the rest of them, I think you can do it yourself. This one is about estimating the sample size. I'll go over this one. It looks slightly different. Okay. All right, so this is about SAT scores. So okay. So SAT score is distributed with the mean of, and so population mean is 1500, and then population standard deviation is 300. And you are interested in estimating the average SAT score of your first year students of your college. You would like to have margin error to 25 points, right? So meaning margin error and 95% confidence, right? That tells us the critical Z score. It's 1.96. Okay. So in this sentence, they are given us two information: margin error, because they want margin error within 225 points, right? Within 25 points. Because given a 95% confidence, so the critical z-score is 1.96. Actually, they want us to find the sample size, right? So there's a formula for sample size, which is critical z-score times population standard deviation over margin error. Square that. So I think that's the formula. Let's go back to the formula sheet, quickly look at that. Yes, here you go. So this is the formula. We estimated the sample size because z-score has population standard deviation over margin error. Yeah, so go back here, throw your numbers 1.6, 300 over margin error 25. Let's square that. We're gonna get a decimal answers, but we're gonna run it up to next whole numbers here equal to parentheses 1.96 and 300 25 and to the second power. We get 553.19. And we run up to next whole numbers to 554. Okay. And yeah, so that's the answer you're looking for. So that's the sample size. I guess I will just go over question 7 anyway. So you guys, so I finish all the questions here. And yeah, question 7 is very similar to question 6, right? And it's very similar nature. And again, it's about margin error. Okay. Go back here, share the screen. We measure 30 backpacks, so sample size 30. And the average weight, so sample mean, right? For those 30 backpacks, average weight is 47 ounces. 47 ounces. Assuming the population standard deviation 3.3, so sigma is 3. Now again, we are using the critical z-score. When sigma is known, critical z-score, and they're telling us is 99% confidence, so the critical z-score is 2.57. One more time, you can quickly look up in the table A2. If you go down, you're going to see 99%, 2.575. And that's the most important thing here. Okay. And once you know this 3 pieces of information, then find the margin error, critical z-score, population standard deviation over square root of sample size. So it's going to be 2.575. 2.575 times 3.3 over square root of 30. And let's see what that is. And again, they want 2 decimal places. Go back to 2.5, 3.3 over square root 30. 1.55. Yeah. So the answer is 1.55. So the next step is sample mean minus margin error get to the lower limit. Sample mean adding margin error get to the upper limit. Sample mean is 47. 47 minus 1. 47 add 1. This one becomes 45. 45. And this is 48.5. No, actually, they don't want this. They actually want, they don't even want us to construct this linear inequality. They just want to put sample mean 47 right? That's sample mean plus minus margin error. Margin error just calculates 1.55. This is not needed. So it's 47 plus minus 1.55.
Where in the question does it tell you it's not needed?
Huh?
Where in the question does it say it's not needed?
Because it's just saying plus minus. When you see plus
Oh.
minus, yeah, it means you just wanna mean and then margin error separately.
Okay.
Yeah, so that's an indication, right? Otherwise, you're gonna see something like this. If you see something like this, that means we're gonna like the question 6 we did earlier. You see trilinear inequality, that means you're gonna do the follow-up steps. Yeah, so okay, so pretty much everything, right? I went over everything on the review sheet except the last couple two. And then question 10, not equal to meaning two tails, right? Because alternative already determines the the test, right? And then here, the last one, the mean weight of male nurses less than, right? Less than has to be the alternative hypothesis less than 187. And then the null hypothesis will be greater or equal to. Or you just if you put just equal to, that's okay. Yeah. The null hypothesis will always have an equal sign. Alternative hypothesis has no equal sign. Okay. So pretty much I review everything, right? I'm gonna record this video and I'm gonna email to you guys. You wanna over this before the actual final? That's okay with me. Okay.
Thank you, Professor. We know
No
you went
problem.
over time.
Okay.
Thank you so
Okay.
much.
No problem. Yes.
Thank you.
Okay. No problem, guys. Bye bye.
Thank
See you
you.
later. Later, right?
All right. Thank you. See ya.
Okay. Jason. Okay, so I can
Yes.
answer one of your last question.
Yeah, question 10.
Question 10. Okay. Very good. Question 10. Yeah. Okay. This question. Okay. I see. I'm not actually question 10 is not a question I want to put on the final, but it's okay. It's okay. I'm gonna show you. Yes. I didn't cover this in the class though. So
Okay.
I'm probably gonna replace it. Just 1 second. Let me quickly replace it. I don't want this question on the final actually. For some reason, no, I copied the wrong question, so I'm gonna quickly fix it. Give me 1 second. So let me go to the. I did want one of the question, but not that question. Yes, I will use the. I'll use this question. This question is better. I'm gonna copy the code. Okay. With that, I'm gonna go to the midterm exam review. I mean the exam review. I'm glad you bring up the question, so I know this one. I didn't mean to put this one there. Okay, and let me just quickly update it. New versions. Should be good. Now let's look at this question together. Also let's change it in the actual files. So we change it here. Yeah, so look at the question really quickly, Jason, and we're gonna go over that together.
Okay.
That's how updating.
It updated already.
Yeah, updated. Very good. So let's go back. We'll start it as And then I'm gonna go that together. Question 10, I'm gonna go to your account. Your question. Do well on homework, right? Just keep up with the rest of them and get it done. And homework
Yeah.
helps. We'll go question number 10. All right, so let me full screen. So this one we're gonna divide into that one by one, right? So divide everything by x. Share the screen with you. Yes. So first one, we get a 3x, right? Second one is 3x squared. Third one is just 8. Last one is 2 over x. So you can look at it as 2 times 1 over x, and then dx. Now we separate into 4 different integrals: 3x dx, right? Minus ax squared dx, minus a dx, and then minus 2 1 over x dx. Are you following so far?
Yes.
Okay, very good. So by the power rule, so this is 3x, 1 plus 1 is 2, 2. This one is ax, 2 plus 1 is 3 over 3. That one becomes ax. And the last one, 1 over x becomes ln of x, ln the absolute value of x. And that's the only tricky thing here, right? So adding everything else just a power rule and constant rule. Good.
The bottom part is the answer.
Yes, the bottom part is the answer. Yeah, that's right.